Your AI system might already be broken. You just can't see it yet. See, this is the dangerous things about AI systems. Most failures are invisible. You are not going to see them directly. The front end will load, your workers will run, your requests will enter, but underneath what is happening? Retries loops forever, jobs are getting stuck, tokens cost spike, and the queues silently slow down. And if you don't have observability, you are completely blind. See, most developers obsess over prompts, models, and response quality, which is okay. You should obsess over it, but at certain point of time, you should ask the bigger question. And the bigger question is, how do I actually see what my system is doing? Because if you don't know what your system is doing, you are running blind. And this blindness becomes very, very critical when real users arrive. Because once the system scales, guesses stop working. And what happens is that when the system scales, users punish the system hard. See, what will happen? Let's suppose a user is there who is continuously facing the retries or continuously facing the same errors. That becomes a very bad user experience and you're losing users and you don't know about. So at least you should know about it. See, logging is not just throwing print statements everywhere, like console log in your JavaScript application or any system out print statements in your backend. No, this is not the way. See, bad logs only create noise. You are not going to get anything from the bad logs, and you might also waste money because, see, every statement costs money when you are scaling. Good logs, on the other hand, they create traceability. And with good traceability, monitoring becomes very easy. Like you can see the difference if you have implemented it. And with good monitoring, proper dashboards can be built. Now, see, I know that dashboard sounds simple and people don't care much about it, but proper dashboards help technical teams to diagnose a system very easily. For example, if you don't have logs, you might take, let's suppose, a 1 day to diagnose a system. With proper logs, proper dashboards, and proper management of those logs, you are going to diagnose that particular system in maybe just 1 hour or half an hour. That happens. So keep that in. Every AI request in production should track at least these six things: request ID, latency, token count, retry attempt, final status, and the sixth and the most important, workers handling the job. See, because at scale you are going to use multiple workers, you are not going to use only one. So you need to know exactly which worker made a mistake or which worker faced error. Maybe it's a worker fault. So you can check that worker directly. You don't need to check, let's suppose, if you have 100 workers, you don't need to check other 99. You just check the error one. And that's how things work. And that's how things should be structured. If not, because nobody is going to check 100 workers. Let's be very real about it. Because what happens is that eventually things fail. And the logs become your only source of truth. Because only then, by seeing the logs, by seeing the failures, you will see, okay, worker number 73 is wrong, and at that time it was wrong. And then you can diagnose it. That's how things work. This is where your systems become debuggable. One AI request may travel through front end, API layer, queue, worker, model provider, and database. And without any tracing, you don't know where delays are happening. You don't know where failures are happening. You don't know which component is overloaded. Tracing allows you to follow one request through the entire pipeline. That's how distributed systems are debugged because distributed systems are way complex. It contains many components. Like we are discussing here, six components. So this database, you can have distributed database, which is a very common thing in these days. Model API. You might be using some other service provider. They might be using some other systems. That becomes common. Your workers. Again, as we have already discussed, multiple workers. So you need to check everyone. It is not easy to check every worker. Queue. Again, you might be using multiple queues also. API layer, again, depends. Maybe the model API changed and you are using older version of API layer. And front end, yes, because see, user experience and user preferences changes with it. So you need to update your front end as well regarding like, okay, this is the new thing in the market or this is the new style people are liking and so on. This becomes important much faster than people expect. One prompt update can suddenly double your token usage, it can overload your workers, and can destroy your infrastructure cost. And the most dangerous part about all of this is that it happens silently. So, token monitoring is not optional, it is operational cost visibility. Now, these are some of the worst failures in production because stuck jobs don't fully fail actually, they just hang forever. Now, what happens is that your worker remains occupied, your retries increase, queues clog slowly, latency spread across the system. So production systems need heartbeat monitoring. If a job exceeds expected execution time, flag it, isolate it, and then inspect it. Otherwise, systems decay slowly instead of crashing visibly. This is your operational control center. A real AI system dashboard must track queue depth, retry rates, failed jobs, and worker utilization along with token usage and latency spikes. The goal is simple. Detect pressure before users notice. Let's say users upload resumes in your AI analysis system. At first, everything looks fine. Then, one worker gets stuck, retries begin increasing, queue latency rises, token usage spikes unexpectedly. Without observability, nobody notices. Now compare that to a monitored system. Immediately you can see which request failed, where it failed, how long it waited, which worker stalled, how retries propagated. That's the difference between guessing and operational engineering. Now you know everything in a monitored system. So you can easily diagnose it, you can repair something, or you can invalidate the request, like whatever error handling mechanisms you want to use. See, everything has a trade. Even this has a trade. Observability is expensive. More logging increase your storage cost. More tracing will add infrastructure overhead, and more monitoring will increase your operational complexity. But without observability, scaling becomes impossible. Like, stop dreaming about scalability if you are not making your system observable because you can't optimize something you can't see. So remember that. See, most AI systems don't fail loud. They decay silently. So observability is the only thing that lets you detect failures early, that lets you control your infrastructure cost, lets you debug the production systems and maintain reliability at scale. This is operational engineering. Once AI systems hit real traffic, observability stops being optional. It becomes survival infrastructure.